for this test, we'll be doing the starch test. Now, starch is it's a complex carbohydrate, and it's one of the macronutrients. So for the starch test, have a starch solution here, and we're following the steps in the lab manual. Right. No, so over poured. Now, key thing is you don't want to. This is not the stock starch that we took from. We mixed this from the stock starch because you don't want to contaminate your stock, right? So you take from your stock and get some at the side, bring your head, leave it on the desk, bring your head to see the bottom of the meniscus, and you pour into the tube where you'll be adding the reagent afterwards. So you have 2 centimeters cubed of starch, and then for the reagent you're just using 4 drops. So we have the dropping pipette here, right? You want to get rid of all bubbles from the dropping pipette, and you want to make sure that the dropping pipette, well, this one, it seems to be leaking, so take a bit of excess because we want 3 to 4 drops exact. So bring this closer. 1, 2, 3, 4. Now notice with starch being present, now we shake it, but with starch being present, notice that it changed immediately to blue-black color, and that says that starch is present within this starch stock that we have here. Now this test, and for the other food tests that we'll be doing, this can be done with regular food. For example, cricks, bread. The only thing similar to what was done with the starch, you want to crush it and use distilled water, right? Crush it, use distilled water, and make a solution, and follow the same steps for if you were to use regular food like, say, bread or cricks with the starch test. Now, for this food test, we'll be testing for the presence of fat within the food, and the food sample we have here is oil, cooking oil, and so fat is one of the macronutrients, and macronutrients, what the body requires, nutrient that the body requires in larger amounts, right? So for the ethanol emulsion test, take off the paraffin from it here, right? If you leave that to the side. Once again, leave the measuring cylinder because for accuracy, right? And ensure we have 2 centimeters cubed. We want to bring our head level to see the bottom of the meniscus. Alright, so that's 2 centimeters cubed ethanol. Add it to test tube. To prevent contamination, we use a different measuring cylinder. So we place this to the back, different measuring cylinder for the 2 centimeters cubed of fat. We're using the same volume of reagent as we're using for the food. So 2 centimeters cubed of oil, right? Bottom of the meniscus. Pour into the test tube. Just shake that quite a bit. Now notice it turns cloudy, right? Now when the mixture turns cloudy, that indicates that fat is present. But the key thing about this test is when we add it to the cold water, and that gets the fat to separate where where you see the fat globules. So we have distilled water. Add some to a beaker here, clean beaker, because we don't want contamination within any of the experiments. Right? And in terms of the volume of distilled water, it's up to you. We just want to have a decent amount so that we can observe the separation quite well. Right? So they are cold distilled water. So it's on ice. Shake, note it, and pour. Immediately everything goes white, right? And if you look here, you'll see there's separation. You water at the bottom, ethanol, and then you have some of your fat globules at the top. Here you have and so that signifies the presence of fat. And the food that we use is oil. Now, as you can use any food, you just need to get it to liquid form. So you want to crush and then add distilled water to have it in liquid form, and then in a solution form, and then you carry out a food test with it. So fat is present in oil, and that's what this test says. Now for this test, we'll be checking for the presence of protein in egg albumin, or egg white rather. So first we remove the paraffin, and 2 centimeters cubed, right? And again, a measuring cylinder, because we want accuracy. On the desk, bottom of the meniscus. Now we have some bubbles. Try and tap lightly, shake to get rid of the bubbles. Okay? We got rid of some, and we want to ensure that the bottom of the meniscus is by the 2 centimeters cubed mark. Pour that inside of the test tube. Place on this side. Remove paraffin. Two centimeters cubed sodium hydroxide. So we have a bit too much here, right? Because this is actually 2.1. Again, this is not the stock sodium hydroxide. We took some from the stock, added to this beaker, because we don't want to contaminate stock. Alright, so this here, once I poured back from the measuring cylinder, there's contamination. This and 2 centimeters cubed, bottom of the meniscus, there's that. Pour into the test tube. And we want a few drops, 2 to 3 drops of copper sulfate. Place this on the side, like that. A bit more. It says 2 to 3, but now shake. And key thing is we want this purple color, purple or lilac color, right? And the thing is, more reagents you add, you end up getting a deeper color change. We want that light purple color like this, right? And so this says that protein is present in egg albumin. Stop. For this test, we'd be trying to find out for the presence of reducing sugar within food. So the two foods are two solutions we have: glucose solution and sucrose solution. Now, the body uses sugar for energy and carbohydrate. Sugar it's a macronutrient because they need it in large amounts, and it's used for energy. Now the thing is, when you take non-reducing sugar, for example sucrose, easily digested, complex carbohydrates, like say for example starch, that's digested or chemically broken down to get your simple sugars, or that's absorbed into the body, right? So let's start off with the sucrose. So remove paraffin. Use 2 centimeters cubed, right? So then leave on desk, bottom of meniscus. Ooh, we have too much there. A bubble, lightly tap, right? See a little bit, move this aside. Bottom of meniscus, right? And so in this instance, since we're using two foods, we have test tubes labeled A and B, and so for the sucrose, I'm going to pour it into test tube B, 2 centimeters cubed sucrose, right? And do something similar, move that to the side. Now this one is glucose. There. Then 2 centimeters cubed. Notice clean measuring cylinder. Right, 2 centimeters cubed. Bottom of meniscus. For that, I'm going to use test tube A. Move to the side. Alright, now next step is to add reagent and let boil for 5 minutes. Now the reason why did the food first is to reduce the amount of time between adding test tubes B and A to the hot water bath there. Alright, now similar, using 2 centimeters cubed reagent. Alright, in this instance Benedict solution. Ooh, that's too much. To get rid of some. Bottom of meniscus, right? Add to test tube B. Two centimeters cubed. Right, bottom of meniscus, add to test tube A. Right, and add to hot water bath for 5 minutes. Right, so notice using the tongs here to add it because, well, inside there is hot. Right, then add test tube A. Ooh, so, right, and we leave it there for 5 minutes and observe it. So we've allowed them to stay in the water bath for a period of time, and what you'd notice is that one of the test tubes remain the same color, and that would have been your, move this to the front. One of your test tubes remain the same color, as compared to the other one, which is now an orange brown color. Now orange brown, that would have been your glucose, which is a reducing sugar, as compared to your sucrose. So similar to the other food tests, these just test for the presence of a nutrient and just based on color changes. And so sucrose is not a reducing sugar, whereas glucose is reducing sugar. And the reducing sugars, they are absorbed into the body much easier than your non-reducing sugars. But however, your non-reducing sugars, are easily digested, so that you have absorption of those as well.